Okay, so I had a request to go over the shapes, the different shapes that you have. Um, and I just thought I'd share it with everybody. Okay, so we basically have a couple of different shapes when we're looking at molecules. One is linear, right? Self-explanatory. So this would be three atoms that form linear. You'd have two atoms, right? That's the diatomic molecule, right? Di meaning two. So then the shape, another shape would be triangular planar. This would all be straight, right? And then you have the bent shape. And then another is the tetrahedral shape. We talked a little bit about that already. And this would be in 3 dimensions, right? So try and make it 3-dimensional-ish, like this is in the background. I can't draw these things. Need a touch screen. All right, so that'd be tetra meaning 4. Then pyramidal, you have 3 on the bottom here. Okay, so these are your basic shapes. And so how you end up with these shapes has to do with the electrostatic forces, right? So in these cases, these guys lay out flat and linear. So a bend shape, a good example of a bend shape would be water, H2O. So covalent bonds, 2 atoms for each bond. Oxygen has 6 valence electrons. Hydrogen has 1 valence electron each, which gives me 8 total. So I've counted for 1, 2, 3, 4. I need to account for 8 more. So I have these 2 lone pairs of electrons, right? And they sit here. And you've seen this a little bit, hopefully, when I was drawing stuff for ionic bonds. And so what happens is these lone pairs of electrons, right? It's just negative charge. They need space. So they push this into this bent shape. Okay, so that's how you can end up with a bent shape. Here's an example. Ammonia, NH3, is an example of this pyramidal shape, right? So you have 3 hydrogen atoms. So each of these hydrogen atoms has 1 electron. 1 plus 1, oops, plus 1. Oh my God, it's awful. Right, plus 5 for nitrogen gives me a total of 8. I've got 3 bonds, so I've counted for 6, so I've got 1 more. So this lone pair pushes these hydrogen atoms down into this shape. Okay, so tetrahedral, methane, right? Hydrogen, 1 electron. Oof, I swear, one of these days I'll get better at this stuff. And so that's 4. So they, again, 3 dimensions. Think about this as in 3 dimensions. I have that like pyramidal sort of shape. So this forms this tetrahedral shape. Okay. So the bend shapes help us determine whether molecules are polar or nonpolar. So let's look at hydrogen and fluorine. Okay. Hydrogen has 1, fluorine has 7. So they just form this one single bond. Again, diatomic molecule. So what's more electronegative, hydrogen or fluorine? Fluorine, right? So we use this arrow to indicate where my negative charge buildup is. Partial negative, partial positive, right? So I'm going to find all the electrons kind of centered around the fluorine. All right, so that's a diatomic molecule. It's linear, and this molecule is going to be polar, right? Because it's got one end that's more electronegative than the other. Carbon dioxide double bonds with the oxygen. Oxygen has 6, carbon has 4, and then another oxygen gives me 6. So I need 10, 16. 1, 2, 3, 4, 5, 6, 7, 8. So I need 8 more. So I have these lone pairs on oxygen, right? Pretty cool. So go back here. There we go. So carbon is oxygen. Oxygen is more to the right. More electronegative atoms are over here. So this is my partial positive in the middle going here. Partial positive going this way. So check it out. Now what I end up with is 2 equal forces, right? And they just cancel each other out. So it's like that tug of war analogy, right? There's this equal pull by the oxygen because of this linear shape. So this is an example of a molecule that is overall nonpolar and has polar bonds. This is a linear shape. It's an overall polar molecule. So if I have 2 fluorine atoms, each have 7, they share 1 electron. That is an F, not a T. And I'm going to spend all weekend practice drawing on my screen. Oof. Okay, but you get the idea, right? Tug of war, equal pull. It's like 2 twins that have been working out the same, right? No one side is going to give out. And so that's going to be a nonpolar. Okay, so those are the different shapes and how they come into play. So I will post that periodic table here that has the different values of electronegativity and what their thresholds were. I talked about it a little bit. So if you take the difference between the atoms and you end up with 0.4 or less, we consider that to be nonpolar. If it's greater than 0.4 and less than 2, we consider that to be polar. What do you think we call them if it's greater than 2? What do you think? If it's greater than 2, we call that ionic, right? And that's a whole different type of bond, right? So if we're just talking about covalent bonds, which is what we're talking about now, they're either going to be polar or they're going to be nonpolar. All right, they're going to have either polar bonds or nonpolar bonds. The overall molecule itself was either going to be polar or nonpolar. Okay. Hopefully you guys followed along with that. Like I said, I'll post that one to Google Classroom. I'll put it in the notes and resources. I'll probably put this one in the comments, a link to this little YouTube in the comments so you guys can check it out. Hopefully this additional practice helps clear things up. Remember, we're just doing an introduction to this, so don't put a lot of pressure on yourselves. As long as you're following along in the concepts, you can see how molecules will have polar and nonpolar bonds and how molecules overall can be polar and nonpolar, then you're probably in pretty good shape because we're going to practice this more next week. But right now, this is kind of the introduction. So hopefully that helps. It was a lot of information. So just let me know. And it's great to get feedback. So when you guys ask questions, it prompts me to make these little videos and hopefully that'll help other people. So please, please, please drop into the office hours and ask me questions. I had a student contact me outside office hours. It just took me a couple minutes to find something for my kids to do while I did it. So uh, I'm available, maybe even a little bored and starving for human contact. So you'd be doing me a favor if you ask me questions. All right, talk to you guys later.